So today is July 23rd, 2014, 6 p.m. Pacific time. We're aiming for 70 minutes. 70 minutes, and that's because previous ones have been kind of long. So 70 minutes. If I start getting close to the 70-minute mark, so about 7:10, and if I look like I'm still going, someone in the chat room just ping me and tell me, hey, you're reaching about that time. Okay, some legal disclaimers here. Lots of disclaimers. This session is being recorded. Legal disclaimer, options presented are my own and not those of my employer. And since we are dealing with Wireshark, just make sure that you are sniffing traffic legally. Today it's not a problem because we're doing trace files and you're sniffing your own traffic, so it shouldn't be a problem. If you work in the healthcare setting, be very careful with Wireshark, especially if you're going to send those trace files anywhere. So you may be in big trouble if you send out healthcare information, personal healthcare information. If you're interested in some legal stuff, here is a legal pretrial order. It's pretty interesting read. Basically, someone used Wireshark to sniff some wireless traffic, and they petitioned the court to introduce that evidence in the trial. And the judge slapped the guy down, kind of, and said, "You're an idiot." So in certain instances, it's okay. In others, it's not. So you may want to read that up. And before we actually begin, any announcements? Any people who have passed CCNA, CCNP recently? Any test takers? Anyone got a new job? Anything like that? I guess I'll start off. In the last 2 weeks, I passed ITIL Foundation, easy test, and CCNA Wireless, a little bit harder. Quite a bit of Cisco Kool-Aid on that stuff. So if you're looking at CCNA Wireless, be prepared to learn things like how many clients can this particular wireless LAN controller take, how many APs can that take, different stuff like that. So in the chat window, we got Abram, got Network Plus, so F got new job, R Savage, CCNA Research, good job. So that's good to hear. And as always, if you hear about a job opportunity, maybe your company's hiring like a person or whatever, you can always go ahead and send it to the mailing list, and that will hit everyone. Okay, here we go. Assume level of participants. I'm going to assume for this first meeting that you guys are all beginners. As the meetings progress, they will get the difficulty level will go up, but it's going to ramp up pretty slow. So this particular meeting is just concentrated on starting Wireshark, doing your initial capture, playing around with some preferences, some colors, messing around with some columns and filters, just kind of playing around, nothing too crazy. The 4 trace files that we have are going to be really easy. You won't see anything that easy in real life. Everything's going to be a lot more complicated, but you got to start somewhere. So we're going to start from the ground up. And if you're not a beginner, if you're a pro at this, maybe you haven't played with Wireshark in a couple years or for a while, this will clear the cobwebs a little bit. If you guys have like a certified ethical hacker or any other advanced security cert, this first meeting will probably be quite boring for you because I know you guys can use Wireshark quite fluently. Okay, not a big deal. That should slow down a bit. This is probably our busiest meeting ever in RouterGODS history. So a lot of people signed up, it's like 73 or something like that. Okay, so future meetings. This one is just on the interface, some basic stuff. Future meetings, we're going to be looking at Wiresharks between routers because this is the RouterGODS group. We're going to be looking at installing GNS3. You're going to run Wireshark between 2 or 3 routers, see the routing protocols. That's always fun to see OSPF, the database files or the database packets going back and across. The DBD, that's always interesting. Looking at EIGRP, BGP hello, stuff like that. We're also going to be looking at pings and ARPs. ARP is very good to learn to look at with Wireshark because if you don't understand ARP on paper or on the book, if you look at it on Wireshark for about 5 minutes, you get it. It's that easy. Later on, we'll be doing some forensics. You'll be taking some trace files. You'll be pulling files out of thin air. So if the guy is emailing a PDF or grab a PDF off of a web page. You can recreate that PDF and look at it. It's pretty neat. And we'll be doing some capture the spy scenarios. So like a spy's up to no good, downloading files, trying to hack into stuff, and we'll try to piece together a timeline of what that guy did. Also in future meetings, we'll be talking about hardware capture cards. Today, we're just capturing on our local computer. If you're doing it on a laptop, desktop, that's fine. And if you're just beginning, that's pretty much what you have. But in the future, if you want to capture on like a trunk link, a 10 gig link, your laptop's not going to cut it. It's going to burn up and go nuclear on you. So we're going to talk about some hardware capture cards, some taps, and we're going to do some wireless stuff, especially with the Air PCAP cards. If you don't have it, don't worry. They're kind of expensive. I've got the N1, which is it's like $700. It's pretty expensive. But you could do some amazing stuff with the Air PCAP card. That's actually my specialty. What I've done, most of my Wireshark experience has been playing around with wireless. So we'll be doing that, and then other topics as we see fit. Our eventual goal is to actually prepare you for the WCNA. So the Wireshark Certified Network Analyst. We're going to try to hit most of the topics in there. And of course, we're going to have a lot of fun in this because it is pretty cool playing around with Wireshark. And finally, before we dive into this, why learn Wireshark? You guys may be wondering, okay, this is ROUTERGODS, why learn it? It's going to help you learn other things. If you're going for like Red Hat, if you're going for any Cisco cert, learning Wireshark will help you learn all the other stuff much quicker. And it's going to make it much more fun than reading in a dry book like protocol, TCP, IP packet formats and stuff like that. Okay, so instant gratification. I know you guys are all about that. You guys don't want to hear too much talking, so we are going to do it right away. Open up Wireshark. And hopefully you read the meetup information that you need Wireshark installed for this meetup. So we're looking at Wireshark, the first pane here. Hopefully you have the latest versions like 1.10.8. Doesn't really matter if you're on Windows or if you're on Linux. Actually, it's a good question. How many people are running Linux? Linux guys. I highly suggest that you guys, if you don't use Linux, that you start learning it because Wireshark is much more fun on Linux. It's a lot more efficient. I like it, and you're going to have to learn Linux eventually, so that's just going to happen. Okay, this first screen, not a big deal. It's kind of like very wizardry. It's very easy to use. You're probably going to go here on the left-hand side. You see your interface list right here. You've got a wonderful start button and your capture options. Always, always, always go to the capture options. Do not start a capture without going to capture options because you need to do a couple things here. First thing I always do is decide whether you want to use the PCAP NG format. Now that's automatically checked. 99% of the time this is okay. But if you're using certain forensic tools such as my favorite, Network Miner down here. I guess I'll show you this right now. So Network Miner, I'll expand this. What Network Miner can do is you can throw in a trace file and it will rip out all the images, all the files, all the host names, stuff like that. So if the guy's been looking at Jessica Alba pictures, you do a trace file, you run it, you throw it in a Network Miner, and you'll get all the Jessica Alba pictures that he looked at. So it's pretty cool. The only problem is that in Network Miner, the free version, it uses regular PCAP files. It does not recognize PCAP NG. So depending on your forensic tool, it may not understand PCAP NG format. So that's why you would decide whether to check this or not. So, if you want, you could just always leave it unchecked and do it that way. Not a big deal whether you use it or not. It's just depends on the tools you're going to run it into afterwards. Okay, another thing is in the bottom right-hand corner of your capture options, you'll see that you've got all these check marked, or most of these are check marked. The one that you may usually uncheck is update list of packets in real time. Okay, update list of packets in real time. So what that is if you have a slow computer or you're just getting slammed with packets, as in you're watching YouTube or you're watching Fuse meeting like we are right now, you're in a meeting, you may want to uncheck this because things are going to be just going crazy. And then when you uncheck this, you'll see that automatically scroll during live capture, that becomes grayed out because if you're not updating a list of packets in real time, you're not scrolling. Okay? If you have a fast computer, it's fine to leave that checked. It's not a big deal. Resolve MAC addresses. What this will do is when you get a MAC address, it'll say like whether it's a Dell computer, an Apple, Samsung, that type of stuff. Usually I leave that checked. It's not a big deal. And transport layer network names. So this will try to resolve the network names. It's up to you whether you want to check or uncheck. If you want to make this a clean capture, you can uncheck all of these and get the most speed possible. But for now, we'll just deal with that. So PCAP NG format, leave everything default, and you're going to pick an interface. And yes, we are going to capture on your live interface. So if you're on wireless, you're going to click on wireless. If you're on a wired connection, click on wired. Notice that you can click on multiple interfaces if you want. Now, if you're not sure, if you have a lot of interfaces here, like you may have like wireless network connection 1, wireless network connection 2. For instance, if you have a laptop with wireless and a card, a USB wireless NIC, you'll have 2. If you don't know which one is active, then you would look in another menu. It'll tell you what packets are flying through. Okay, for now, pick on the network that is your active network. See this buffer right here? 2 meg buffer. Right. We're going to change that later, but for now, 2 megs is okay. You can click on Manage Interfaces right here. Click on Manage. These are our local interfaces. You can hide these from later on. Ooh, remote interfaces. This is pretty cool. I don't have any remote interfaces right here, but what you can do is you can capture on another computer and then send that capture through your network to a central Wireshark computer. So like a centralized analysis machine. So this is pretty cool, remote interface. So run the sniffer, capture the packets on one computer, and then send them all to another computer. Okay, we'll click on Start. Now, because so we have no packets here. Okay, that's because I'm not on wireless. So if you don't see anything here, you'll be looking down here, it'll say no packets. So if you sit here for 5 seconds and you don't see any packets, then that means you don't have a connection on that particular interface, because sure as hell, if you're on a Windows machine, as soon as you start capturing, you're going to get packets because Windows is noisy as hell. So if you don't see any packets, just simply go up to Capture Interfaces, and let's see here, we'll stop it. And of course it tells me, hey, no packets captured. Well, that's fine. That's okay. So you're going to uncheck on the wireless, and we will go local area connection. And you'll see in this list right here, I'm going to pull it in the center here. My local area connection, the number of packets is incrementing, decent amount, and that's because I'm running Fuse and I'm talking to all of you guys. So, and it says packets per second, about 100, 120 packets per second. So that is my active connection right now. And we'll click on Start. And now we get the wonderful list of packets, right? Okay, so we are dealing with our main capture window. First of all, you can change the font. You can zoom in a little bit just by clicking this plus sign. So this is important if you have a 1920 by 1080 screen, right? Something like that. That looks kind of ugly, but you get the point. So we got different panes here, different sections of the interface, and we'll just kind of go through this. Up here is your toolbar up at top. You've got your filter line right here. This is where you could type in stuff like, you could say, give me all TCP frames, TCP packets. And it's quite easy. You just type in TCP. And you'll notice that as you type it in, it's read until you get to the correct syntax. So if I type in TCP, the line turns green, I hit enter, and it's going to filter everything out. Actually, I'm going to stop my packet capture because I've got 36,000 packets. I've got some crazy amount of packets. If I just wanted IP packets, I type in IP and hit enter. Right? So it's pretty easy. You could do more. We'll be doing more advanced stuff later, but I just want you to do your first filters. If you wanted to look up DNS packets, very simple, DNS, and hit enter. All right, so you see all this wonderful DNS stuff. Holy crap. That's not too much. Right? How many of you here how many of you were able to see a filter or see all of your packets and filter it by, let's say, DNS and hitting enter? Yeah, so it's pretty easy. It's pretty easy. And you'll notice that in the protocol section, you have a column here called protocol, and it lists DNS here. If you want to clear your filter, you could either go back into the filter box and hit backspace, or you could just clear it right there. Okay. So that's the filter. Now, to the right of the filter, you can make complicated filters by clicking this expression. And then over here, you can see I've got these two things called CDP and filter. These are buttons that I have made. You won't see them on your screen, but we'll be making these buttons later. What these buttons do is, I shouldn't have any, I guess I do have CDP, because there's a Cisco router on the other side. What I've made here is if I click that button, it automatically inputs in CDP. And so you can see that on the other side of my connection is a Cisco router. Okay, we call it MDF. Well, you can kind of tell that I'm at work now. And I'm on port 911. Right. This filter, I forget what this was. Oh, TCP stream. That's a filter I'll be showing you later. And we'll also be making special columns for that as well. It's a very powerful filter that we'll talk about. Okay, so we'll clear that out. So in the center here, this is your frame list. You can see it's in numerical order. You could scroll through it if you have a mouse wheel, just really scroll through it. You could also use your cursor key, it's fine. And you can notice that when you highlight a particular number, like in my instance, I'll just go back all the way up to 1 here. Okay, so frame number 1. The relative time starts at all zeros. I've got some information there. As I click through the different frames, you can see the information in this bottom pane right here, the second half, changes because that reflects the current frame that is highlighted. So if I click on frame 1, I've got the information down here, the contents. I've got kind of like the raw contents on this very bottom pane right here. Right. So how many of you are used to like a hex editor? How many of you have played around with a hex editor? Possibly in Linux, possibly in security, or back in the real old days of computers, right? So a hex editor, very similar. You see all this stuff and it gives you the real representation of, what the humans would see. Some of you may have used a hex editor in possibly making a computer or making an application work without a license, right? That was back in the days. We won't talk about that. Now here's something some people, or a lot of people, don't realize. I'm just going to resize this a little bit. So in this details pane, now if you pick a UDP packet, and if you are having trouble finding one because you have like 50 billion packets, just simply type in UDP, enter. It'll filter out all the UDP packets. pick one. Doesn't really matter which one it is, but just pick any one. And you'll see it gives the information down here. We have a frame, Ethernet, IP, UDP, data, right? Now yours might have more information, but that's what you should be seeing, at least. So frame and Ethernet. Frame and Ethernet. From the OSI model, what layer is the frames? What layer is Ethernet in? Layer 2, yes, correct. Going down here, what layer is Internet Protocol? Layer 3, yes, correct. So do you see kind of a pattern here? As you go down in the details of this packet, it's going to start with layer 2, layer 3, layer 4, it's just going to keep going up and up. So you may be wondering, okay, well, what about layer 7? I want to see some layer 7 stuff. Well, here's a trick question. Why don't you see any layer 7 stuff in this UDP packet? Yeah, we might want to look at some, it's in the data, it's hidden in there, right? But a better way to see this is if we looked at TCP information, or even better, if you go to a web page, go to any web page. So we'll go to, watch this, ESPN. ESPN is kind of like the poster child web page that people go to when they're first learning Wireshark, because you may think you're just going to ESPN.com, but if you look in Wireshark, you just saw that you went everywhere. And I believe I need to start this up again. Always remember to have your capture going. There we go. So we go ESPN.com. Our capture is running. Then we stop it. So it's just a simple web page. But how many packets did that ESPN, how many frames did you grab out of that ESPN front page? Several thousand, right? Now if I turn off TCP, it's probably a hell of a lot more than that. So look down, take a look at your ESPN when you started ESPN and when you finished, and you should see somewhere in the neighborhood of 7,000 packets. Okay, those frames and packets came from ads, they came from DNS entries, they came from a whole bunch of crap that you may not have realized that CNN is redirecting you to. So now in the filter, we're going to type in, let's see, HTTP. Enter. All right, these are all the HTTP. You can see source and destination. So for those of you who went to the ESPN webpage and you're looking now at the HTTP packets in Wireshark and you filter them out, who can tell me what the IP address of ESPN is? Yep, 6871.212.186. Now, you may get a different IP. It just kind of depends on how they do their load balancing, the round robin stuff. And of course, you're going to see your own IP address in there as the source. So you can see source is my computer, destination is ESPN. Then we're going to have stuff coming back. Okay, so select any HTTP packet, and you can see we got frame, Ethernet, IP. We're going up the OSI, the layers here. We get TCP, and we get HTTP, right? Just going up the layers. Any questions so far? We're just having some fun here, going to ESPN, doing a simple filter, and just playing around a little bit. Okay, so we have a question, small files, or did you disable reassembly? I believe I might have. For now, it doesn't really matter if you disabled reassembly or not. We're going to get into exactly what that is. So I have a sheet of what I do when I open up Wireshark, and it's also in my profile. I'm going to kill ESPN. That's just a horrible page to have open. Okay, so we were able to capture a packet. We talked a little bit about the capture options. interface elements, and hopefully you can see that buying a good screen, hopefully a 2560 wide screen, or if you have the money to plunk down on a really big screen, you know, that's 3,000, 4,000 pixels wide, then you can see quite a bit. And right now, thankfully, the prices on those wide screens has gone down, so you could pick them up at Costco now for 250 bucks. It's the LG screen. Recently they had a deal like 40 bucks off, so that was a insane deal, and I picked up 2 of them. So, and this meetup is not sponsored by Costco. Wish it was, but it is not. Okay, customizing Wireshark. We're going to add some new columns. We're going to play around with some colors, and we're going to play around with some profiles. Now let's do the profiles first because that's an easy one-shot deal. Okay, you could clear out your filter if you want. So notice the colors as you scroll through. Some are colored green, some are colored blue. You may have some black ones in there, some red ones, all different types of colors, right? Now if you pick on any one of these colored packets, if you right click on it, in the middle you're going to have colorize conversation. And you can see Ethernet, and you have all these different options. So basically what you could do is you could recolor these if you want. You can also create your own color rules. You could say something like all CDP packets are black. All OSPF packets are red. You know, stuff like that. So Anthony has a question, does the profile survive after upgrading Wireshark to a new version? That's a good question. I always make new profiles, so I don't know if it actually survives, but what you can do is you could save them in some nice place before upgrading just to guarantee that it survives. Yeah. And they did have an interface change. They moved from, I think it was GTK to QT. Okay, profiles. You can see down here, I'm running the default profile. So what a profile is
and exit chimes are off.
So what you can see here is we've got colors, we've got columns. The way you do your colors, the way you do the columns, that's all stored in your profile. Now, everyone kind of has their own profiles, and you could share them. You could share them around. The forensic guys have their own profiles to look at like emails and things pop out at them. Router guys, the network guys will have another profile. You could have profiles between teams, stuff like that. So profiles are very, very important. And if you make these long filters, it's you don't want to have that. You have to remake them all the time. And it's very nice to just give someone a profile and just say, hey, dude, if you open up this profile, you're going to get these 5 buttons and these things are going to be colored black. Just look for that. All right. So right here, if you go to the bottom right corner at the kind of the very bottom where it says profile, yours is probably on default. If you left click on that. So this new version, the default, the colors are kind of muted. The classic version has what I call clown colors. I don't know what else to call them, but everything's like really bright, very contrasty looking, and you can see that my font reverted back to the normal size, and that's because when I was in my default profile, I had changed the font. I had messed around with this zoom option here. All right. So when you exit out and come back, your default profile, it's going to remember everything that you did, which is usually a good thing. A lot of people like the classic clown color colors here, which is all right. It's not too bad. Right, and the way you have the column sized is also saved in your profile. Okay, now if you go up to Edit and Configuration Profiles, you can see in here you can make new ones, you can copy them, you can do all types of stuff if you want. You can do the check marks. I've never played around with this Bluetooth one, but you could do different things with them. Okay, so profiles are pretty cool. Okay, let's add in a new column. Oh, also, so in the future, someone in this group may be making a profile that you'll be able to capture traffic on a link between two routers, and it's going to automatically highlight and have buttons for the common routing protocols like CDP, OSPF, that type of stuff. So you'll be able to download that profile from someone, not saying who. And then hopefully the forensic guys will make a profile available. And you could easily find them on the internet. Okay, making some columns. Now, let's go back to my default profile. Okay, so you see your columns here. This is the default option. You see the number of the frame, goes from 1 to whatever. You got the time. This is relative time. So starts at 0 and then it goes up. You see these are like hundredths of a second, milliseconds, and then when it actually goes up to 1, that's 1 second. So when I opened up ESPN, in less than a second I just got hit by everything. Source IP, destination IP, protocol, length, and some info. Info is kind of is very useful here. Gives you a summary of what's happening. So if we want to make a column, it's pretty easy. And there's columns that I always make. So let's go up, hit the home key, get back to number 1. So if you go up to Edit and Preferences, under User Interface, it's your first option there. If you expand that, you're going to get columns. Now, as you can see, all of these are checked. If for some reason you don't want info, you can uncheck that, click Apply, and you'll see the info column disappear. I kind of like that, so I'll get it back. Now, to add a column, very simple. You click Add, and it's saying title, new column, field type, number. We're going to change the title. My first column. And for field type, let's click the drop down, and you can see these are pre-made columns that you could put in. Now for you router guys, this may be interesting. Look at that top guy right there. What does that say? What do you have for your top option? VLAN ID, 802.11.1Q VLAN ID. So if I had a network tap attached to a trunk link, what would be cool about looking at the 801Q VLAN IDs? I could see packets per VLAN, right? I could see like, this is on VLAN 60, this is on VLAN 80. Yeah. Now, if you're capturing on a trunk link, you better have some type of dedicated capture card, or if it's like a 10 gig line, your laptop's going to probably melt. But you do have that option. Okay, so a couple things here. Delta time. Delta time is going to show the difference in time from the last packet. Okay, delta time from the last packet. So let's click on that. And then click OK. You're going to see a column to the right. Now, if you want to move this, you could just drag it wherever you want. Okay, so you can see that what this is showing is the time from the last packet. So on this particular one, 000, so it happened very, very quickly. I got hit with this frame, this packet, very, very quickly. 620 came in pretty much instantaneously after 619. Now if I sort this column, let's see if I can find one, two packets that were a little far apart. So I can click this up here. And let's see what our biggest number is. It's not too bad. 1/100th of a second, or 18/100ths of a second. Okay, so 18,000ths of a second actually, sorry about that. So you can see kind of the range here. Now if you see packets that are like a couple seconds apart, you would be kind of interested in that. Yeah, either maybe you have some network congestion, maybe the web server is kind of doing a hiccup. This is one of the things I always do when I'm analyzing database problems. So, how many of you guys have had that wonderful fight with the Microsoft SQL database administrator? Right? You work at a company, you run MS SQL, and they say, network slow. I need more cores. I need more bandwidth, blah, 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 right? And then you come back and you say, well, you've got 8 cores. I gave you 64 gigs of RAM, and you're on a 10 gig link. I can't give you anything faster, and your network utilization is 1%. So it's not that, right? So with Wireshark, you can come back and you can say, hey, the packets come back pretty much instantaneously, or the packets are slow. So you can nail down that, okay, it's your server, it's your SQL query, you were an idiot, you did select star from all or whatever, and you went to University of Phoenix and you got your SQL cert from there, or whatever, right? So Wireshark is very, very cool for diagnosing and proving your case against the database guys. Right. So this is your delta column. So that's a column I always make. There's some other columns I always make. If you go back up here to Edit and Preferences and go back to Column, let's add another one. And let's just call this second column. It's a horrible name, but we can always change it later. Okay, so that absolute time, that relative time kind of sucks, because if you get sent a trace file, it's like, dude, okay, it's just counting up, doesn't really help me too much. Okay, so we have absolute time, we also have UTC time. Let's go with UTC date and time. So it's down at the bottom, UTC date and time. Click on that. I guess you should probably call this this column now UTC. Then we'll click OK. And down here on all the way over on the right hand side, you have a column that shows UTC time. And I'm going to move this over here. Drop it down there. Okay. So it's giving me date, time, and UTC, so that looks pretty correct. And that way when if you're all working off the same profile, you could be looking at the same thing. So hey, look at that packet at whatever time. Although with big files like this, you would be saying, okay, if you're all looking at the same trace file, hey, look at number 6914 or look at 6918. That way you guys are on the same page. Okay. Okay, if you want to remove a column, pretty easy. Right click on UTC, we're going to nuke it, remove column. My first column, right click, remove it. And if you're used to Excel, this should make a lot of sense to you, because in Excel you could hide columns, that type of stuff. You have the same functionality here. Okay. Let's take a look at another column that I like using. These are part of my common filters: TCP stream and TCP host. TCP stream, what's that all about? Okay, so you're looking at this trace file. This could be like 30 billion packets long. It's just a bunch of gobbledygook, right? It's just like, what the hell is going on here? It would be nice to kind of number the streams, like, oh, okay, this is the first TCP conversation, this is the second TCP conversation, that type of stuff. And you can do that here in the filter box by typing in TCP stream, and if you hit enter, these are the different start of streams here. But it's better to do this in a column, and let me show you why. If you go up to Edit and Preferences, we're going to go back to columns. We're going to add a column called TCP Stream. Now, if you look in the field types, you'll notice that there is no option that's called TCP.stream. And that's because this is a custom one. Now, I have a bone to pick with, yeah, it's in alphabetical order. Yeah, custom is where it should belong. But really, they should have put custom either at the top or at the bottom, because you're going to be making a lot of custom columns. So why they buried it in there, they should have just added at the top or the bottom. Okay, so if you pick custom, then in the field name, that's where you could type in TCP stream. And watch what happens when you click OK. You're going to see something really awesome here. So as you scroll to the right, okay, so that's your new column. We're going to move this over a little bit. So watch what happens here. Okay, so we have zeros. Okay, that's fine. As we scroll through here, so this is telling you which conversations, which TCP conversation the packets belong to. So this was conversation 15 in between there and there. That's conversation 10. And just kind of with this, you can kind of see, like, man, 10 goes on for a little bit. We have 11. It tells you when things start and stop. So later on, when you need to carve out a file, if you need to rip out a JPEG, stuff like that, looking at the TCP stream number is going to help you a lot, because without that, it's going to look like this, and you're going to be going, what, where do things start and where do things end? Okay. That's the TCP.stream, making that into a column. Now the HTTP host one, that's pretty interesting. If we go into filter, let's just kind of get a quick look at how that looks like. HTTP.host. Okay, it's giving us just HTTP stuff. If we expand out the details pane right here, we expand out HTTP, what we're looking at is this line right here, host. You can see espn.go.com. So we want to be basically looking at the names that these HTTP files are going to. So it's going to be pretty easy. Once again, we're going to make a custom column. Go to Edit, Preferences, and Columns. I'm going to add a new one. I'm going to call this Host. Field type is going to be Custom. There we go, Custom. We're going to call this HTTP.host. Now, if you just stop at the dot right there, you'll see that it tells you everything that you could type in. There's a lot of these that I have never used. HTTP cookie could be interesting, could be very interesting, but for now we'll do HTTP host. That kind of reminds me of, I don't know how many of you used the old Dreamweaver. I don't know if Dreamweaver is still sold, but it was kind of like that. You type in a command and it likes to fill in the stuff for you. So click OK. We're going to have to scroll to the right a bit. Oh, wrong pane. And look at that. New column. And now I can see for every frame, for every packet, I can see what host name it belongs to. This was all from ESPN. Who knows what doubleclick.net is? You could probably guess by looking at the info panel. Doubleclick.net. It's ads, yes. Kind of makes sense. CNN has a lot of ads, or ESPN has a lot of ads. You're going to be served with all of this. Oh, look at that. ESPNCDN.com. So looking at this, ESPNCDN.com, there's an A in front of it. Does that kind of tell us that ESPN is probably using a content delivery network? They're spreading their load around different servers around the world. Yeah. Scorecard research. We got, let's see what else. We have some Google syndication there. W88, what the hell is that? But, some of these are interesting to go to, just outside of the page, if you're ever interested in like all these different ad companies. Yeah, Anthony says no scripted. Yep. Do it in your browser. Don't give them kill all those ads. All right. So looking at the http.host is really, really awesome. Really cool thing to use. And it's also quickly to, one of the things that you'll probably use Wireshark for in the corporate environment is a common scenario. You suspect employee is slacking off. He's showing up late to work. There's not enough productivity coming out of him. He's getting late. He's late for projects, that type of stuff. So you do a trace, and you can look at the http.host, filter it out that way, and you can say, well, the guy's going to Facebook, he's going to eBay, he's going to dice.com on a corporate network, so he's an idiot. Stuff like that. It's kind of a red flag that he's just not interested in stuff anymore. Yeah. So, very good way of yeah, as someone says, great means to get URLs you want to ban. Now, Wireshark it might not be the right tool for that. Hopefully your company has like a blue coat or something like that, some type of proxy, and then that's a kind of an easier way of looking at what websites your people are going to. Hopefully, maybe they're logging by a username or something. Okay, did anyone have any problems making that http.host column? Should have been pretty easy. Okay. Colors, profiles. We'll save colors for a later time because we're getting up on 56 minutes. So how many of you have downloaded Baby Steps number 1? Baby Steps number 1. Okay. Cool. So baby steps number 1, that is very simple. Router 1, router 2. I did it inside of GNS3, so there's no other traffic, and I started a capture. So I'm going to go ahead and open that guy here. Okay, so you should be looking at a file with about 99, well, it should have 99 entries in there. And all this was a very, very simple 2-router topology. I put one side as all 1s, and I put the other side as all 2s. Now you can see in here that we have, just kind of scrolling down, if you look at the stuff in here, you'll see a destination, protocol, all this stuff. In the protocol you can see CDP, and it's colored out. You have some loopback, stuff like that. Now, this loopback right here. Okay, if you go to 14, 15, and 17. Okay, you can see some MAC addresses here. Now, if you don't know what the loop protocol is, don't worry about it, because I'm going to, you definitely know what it is, but the name is slightly different here. So for those of you guys studying Cisco stuff, which is probably most of you, what is that thing that the router does on the Ethernet interface that makes sure the other side is alive? What's that called? It's a hello, keep alive. Yep, that's a, it's a hello timer, keep alive. How often does that keep alive happen? I got all different numbers here. Okay, so this link had no other protocols on it. I just put an IP address, I turned it up. That's it. So if we look at number 13, look at your trace file, 13. See, it happened at 24 seconds, yeah. If you look at number 15, it happened at 34 seconds, so 24 to 34 is 10 seconds. Okay, we have 15, 16. From 16 to 17, it goes from 34 to 44. That's 10 seconds. From 18 to 19, it's 10 seconds. From 20 to 21, that's 10 seconds, 54 to 64. From, let's see, 22 to 24, that's 10 seconds. So if we want to just filter this protocol out, just type in loop in the filter box there, hit enter, and it's going to filter out, it's going to kick out all the CDP and other crap, right? So now this will make more sense. So if we kind of look through this, how often is this happening? Does it look like about every 10 seconds? Now you have these bunched up, and that's because they're flipped, so it's the other side talking as well. So would you agree that this is happening every 10 seconds? One side is sending every 10 seconds, the other side sending every 10 seconds? Yeah. So if you look up the loop protocol, it's the keep alive, it's the Cisco keep alive. And next week, I'm going to show you how to get into the interface. You're going to kill the keep alive, and these will stop coming. They'll stop. If you're crazy, you can go in and you can make the keep alive every 1 second. And you're going to see in your Wireshark, every second, you're going to get this loop protocol. Right? So Wireshark can also be used to solve arguments. You can kind of see, oh, the keep alive happens every 2 seconds, every 1 second, every 5 seconds. No, just run the trace, and you can see right here that it's happening every 10 seconds. Now the source and destination, you can see I've got two different IP addresses here. They're slightly different. It can be hard to read because they're very close, right? So if you're looking at that, actually I think on this particular one I think I just had one side up. Yeah, I just had one side up, the link was up, and it was just sending the keep alive. Okay, length is always 60, and if you go in the data, it's all, it's nothing there. Yeah, this was from a 3725. Right, the data is all zeros. Now let me ask you a question. The packets that you saw before, there's like TCP, HTML, all this, ping, stuff like that. If you go into any types of those packets, you always have a data field. Do you think it's possible that if you knew what you were doing, that you could possibly fit some data in here, hide some data, and maybe there's a guy on the other side, he has a sniffer, and possibly if he knows what he's doing, you could actually send messages to each other? Yeah, very, very possible. Now, when you look at it in Wireshark, you'll just be like, yeah, whatever, I see a loop. This does not look that interesting to most people, because you would just look at it and go, oh, whatever, I see some, these are just hellos. You would instantly dismiss it. But if you knew what you were doing, you could be having a full-on conversation. You could be stealing documents and just hiding it through what looks to be CDP, keep alives, or pings. Was all the rage like 5 years ago. ICMP tunnel, covert channel. Yeah, I know you guys learn if you do like a certified ethical hacker. I think you learned this. CISP is, maybe they'll do like a paragraph on it. But SANS and GSEC, those are the ones that talk about this, and they'll tell you how to do it. It's pretty cool stuff. All right, so just keep that in mind. You've got some data here that you can play with if you want. And there's a program out there called Ostinato. It's very cool. I'll spell it out here. Resources. Ostinato. I'll put a link in the hackpad. There you go. Okay, so if you look at the hackpad down at the bottom, there's a link to Ostinato. What Ostinato does is it's the opposite of Wireshark. Wireshark sniffs traffic. Ostinato lets you make traffic. So what I could do is I can make a flood of ARP responses or ARP traffic, and the MAC address increments by 1 every time. I could pad the data. I could hit you with a bunch of pings. And when you look at it through Wireshark in a certain way, it makes a happy face, stuff like that. Yeah, you could play around with QoS settings as well. Lots of stuff you could do. Once again, not that easy of a program to use. It's not that user friendly, but it assumes that you have, you got skills. And it's one of those programs that are used a lot in like Capture the Packet and the hacking contests at DEF CON. Okay, let's quickly take a look at trace number 2 because we're coming up on the 70-minute mark. We're going to have some fun looking at trace 2. Baby steps number 2. And clear out your filter. No, iPerf is slightly different. Actually, very different. Although iPerf is a very, very nice program to use. Okay, looking at baby steps number 2, this is a trace on a VM, a Windows 8 virtual machine, and I like running Wireshark inside a virtual machine because it's you can clean out a lot of the noise out there. But all this is I disabled all the crap like IPv6, network discovery. I mean, I did all this stuff to make it as quiet as possible. I killed the tiles, so let me bring up the VM here. Okay, so hopefully all you guys can see my Windows 8 VM. Right, so Windows 8 VM, if you go into your network options in network and sharing, in advanced sharing settings, in private you see like turn on, all that stuff. So this is the default, everything's on, and then if you go into your adapter settings, you'll see that pretty much everything is checked. You go into your properties, right? You have the LLDP, you have IPv6, link layer, all this crap is checked, client from Microsoft Networks. So this just makes everything noisy. Now when you uncheck that, you have kind of a much quieter computer. So this was done over, if you scroll down to the bottom, 600 seconds, so 10 minutes, 149 entries in 10 minutes is very quiet for a Windows machine. So what do we have here? You can see NBNS, so some type of name resolution, net BIOS, yeah. Who remembers that other one, NetBUI? Who played around with NetBUI? Any NT4 MCSE guys in the house? Oh yeah, NT4. That was awesome, wasn't it? Disable to enable. Remember that? Okay, so LLMNR, link layer multicast name resolution. That's what you get when you have that discovery crap on. Okay, we got some TCP, some ARP, right? DHCP v6. Awesomeness. IGMP v3. Right? It's just noisy as hell. So just to give you kind of what happens normally on a quiet Windows 8 computer. This is quiet. Now if we go to craziness, okay, this was also, let's see what we got here. At the 600 second mark, it was slightly more, 176 packets. It's not that much more, but you can see that, well, that's, what do we got here? Some more name resolution, more stuff here. ICMP v6. Yeah, we could actually go up here to filter and just filter by NBNS, and that'll filter all that crap out. So you can see here that 192.168, 128.128, that's the IP of my machine. .2 is the gateway. .255 is broadcast. Right, just kind of looking around. Quite noisy that that one is. Now a lot of people get kind of scared when they see all this. If you do a Wireshark on your Windows computer, and if you see like a crap ton of this, what you may want to do is in your network neighborhood, if you have a lot of printers, some mapped drives, if you have a lot of resources in your network neighborhood, guess what's happening for all of those? So if you have a network printer what's happening is it's going out and trying to discover a connection to that network printer. And all of your resources are trying to do that. Your laptop's just shooting all this out. So if you clear out your network neighborhood of all that junk, you're going to see that this NBNS is going to go way down. Okay? So this is one of the hells of working with a Windows network. If you have like a 500 computer network and they're all on the same subnet, for whatever reason, and you run Wireshark on your trunk link, yeah, have fun with that, because you're going to see a lot of stuff. Or you capture on the switch and you aggregate it to your Wireshark. You're going to have fun looking at all that stuff. Okay, so we're up past the 70-minute mark. That was just a real quick and easy look at making some columns, looking at some filters, just an easy introduction into Wireshark. The other sessions will get more fun, but before we end, any questions about what we did today?